Okay, today we are going to talk about slope. And slope goes right along with everything we've been studying this chapter. It goes along with the idea of rate of change. In fact, you can see right here, they say slope is the rate of change. And I want you to write this down. I want you to write constant rate of change and draw an arrow to the word slope right there, because that's exactly what slope is. It's a constant rate of change. So pause for just a minute, write that down. All right, so slope is the change in y over the change in x. It's the vertical change, that's the change in y. Remember, the y-axis goes up and down, that's the y-axis, over the change in x. X is the horizontal axis. We talked in a couple of the classes about this idea. We call it the delta. So delta, which is the Greek letter that mathematicians have used for the change in. So when we look at delta, we talk about the change in y. So you'll see throughout this conversation about slope, I am going to abbreviate it like this: the change in y over the change in x. As we go through, you're going to think to yourself, hang on a minute, there's nothing new here. I've been doing this all chapter long. And the answer is yes, you have. Remember, the power of the videos is at any point, if you want to, you can go ahead and pause the video, go back and look at something you've already done, or you can pause to check up on your notes. So let's go ahead and take a look at this example of slope. The table shows the length of a patio as blocks are added. No blocks, no length. That makes perfect sense. 1 block, 8 inches, 2 blocks, 16 inches, 3 blocks, 24 inches, and 4 blocks, 32 inches. Before we go any further, let's go ahead and label this as the x-axis, and you can actually see it down here, the number of blocks, and this as the y-axis. And that would make sense. The number of blocks would control the number of inches. So whenever we have an xy graph, the x value is the independent and the y value is the dependent. So they have laid out 4 points where the line crosses an intersection of the lattice. They are the 4 points from the table. In fact, there are 5 points in the table. Go ahead and put an extra point right there. Let's start by labeling these points. So this first point is 1 block, 8 inches. 1 block, 8 inches. This next is 2 blocks and 16 inches. Let's go ahead. I'm going to zoom in on the graph itself just to make it really easy for you to do this work. There we go. The next is 3 blocks and 24 inches right there in the table. And the final is 4 blocks and 32 inches. So let's scoot over here and look at their definition of slope. Looks like I need to zoom out just a little bit. There we go. So let's look at their definition of slope. The slope is the change in y divided by the change in x. Let's use that notation that I showed you a moment ago. The delta of y over the delta of x. The change in y over the change in x. So they used 2 points out of the graph. 2 points out of the table. So they used the point 24, 3 right here. So the y was 24, that was the number of inches. The 3 was x, that was the number of blocks. And they used this point. The 8 was the number of inches, the y value, and the 1 was the number of blocks. Let's put one more time. Let's get in the habit of this. Put delta y over delta x. All right, the creaking door is not some mystery thing. It's my wife saying that she doesn't want to listen to a definition of slope. So then we had 24 take away 8 is 16. 3 take away 1 is 2. And that simplifies to 8 to 1. Not surprising. 8 to 1 would be our unit rate. If we broke this down, we'd have a unit rate of 8 to 1. I want to point something out to you. I want to be really clear on something. They went ahead and they did this right here. Go ahead with your pencil. Be sure you're doing this in pencil. So notice their y change went from 8 to 24. That was the 16. And their x change went from 1 to 3. That was the 2. What if they had picked different points? Let's undo those things I just did. Let's get rid of those, including that. And let's pick a different pair of points. Let's go from 1, 8, just to 2, 16. Notice the change from 8 to 16 is 8, and the change from 1 to 2 is 1. And that gives us also a change of 8 to 1. So let's say we had picked this point and this point. We would have our change in y would be from 16 to 8. And our change in x would be from 2 to 1, and that would also simplify to 8 to 1. The reason I'm pointing this out is sometimes students say, well, what if you pick different points? It doesn't matter which points you pick. In fact, let's prove it one more time. Let's take that one, get it out of the way. We know that that worked. Let's get rid of this. So you can erase this with your pencil. Or if you're able to, you can draw this next one over it somehow. And let's do one more. Let's say we went from 1, 8 all the way to 432. So notice our change in y, our delta of y, is equal to the difference between 8 and 32. We're going from 32 to 8, or 8 to 32. So 32 take away 8. And our change in x, the delta of x, is from 1 to 4. So 4, take away 1. We always do the biggest number minus the smallest number, but we make sure, notice, I want to point this out, this 432 right here is that point right there, or that point right there. So we have to keep those together, the 4 and the 32, the 1 and the 8. If we finish that out, 32 take away 8, 24, 4 take away 1 is 3, and that also simplifies to 8 to 1. So here our slope would be 8 to 1, or since 8 to 1 equals 8, we would just say that the slope, which was 8 to 1, would be 8. That would be our final answer. Somebody said, what's the slope? We'd say it's 8. All right, so let's go down and take a look at this first exercise. Now, you've got the paper in front of you, so I'm scrolling down the screen, but you've got all these notes. So look back at them as you do this first exercise. So you've got a table. Step 1, pause the video and put all of these values as points in the table. Go ahead and do that. Okay, let's put in all the points that you put on the table. So we had the point 112. That is, go ahead and remember now, the number of cases is the x value. So this is our x value. And the juice bottles is the y value. And that makes sense. The cases control the bottles. The cases tell you how many bottles you have. So let's do the very first point, And let's write under here how that point's going to look. It's going to be the x, then the y. So it's going to be the x, then the y. One case, 12 bottles. Go ahead and label it. One case, 12 bottles. All right. Now pause again. If you weren't sure how to start and now you're going, oh, I see the pattern. Pause it and finish putting the points on the graph and then start it up again. All right. The next point is 224. 2 cases, 24 bottles. Remember too, with the videos, at any point if you start thinking, oh, I didn't get it, but now I do, pause the video, catch up on the work. That's going to be better for you than if you just watch me do it. The next is going to be 336, 3 cases, 36 bottles. And the final is going to be, let me get a different color here, we'll use our orange. And the final is going to be 4 cases and 48 bottles. 4 cases and 48 bottles. Then we're going to draw a line all the way through that. We're going to start at the origin. It makes sense that our line would start at the origin, because if you have no cases, you would have no bottles. We're going to put an arrow, because it also makes sense that if you kept going, if you had 5 cases, 6 cases, 7 cases, and so on. And now we want to find the slope. So we can take any 2 of these and find the slope. Let's take those 2 right there. So we're looking at the change in y, the delta of y. Well, this point, and I forgot to label the rest of mine, so I'm going to go back. Hopefully you did this. I got so excited about slope, I forgot to label the rest of them. If you were following my lead and you forgot to label them, would you pause right now and get them all labeled? So there are all the labels. That 448 doesn't show up great right there. Let me just fill that in. 448. It's like we're getting ready for Halloween. So we've got the change in y from 12 to 36. So we would do 36 minus 12, which is 24, over the change in x, the delta of x. So for that same set of points, x changed from 3 to 1, which is 2. We simplify that. We get 12 to 1, which is 12. Our slope, not spelled well. Don't tell Mrs. Rogers I couldn't spell slope. Our slope is 12. We would get that same slope if we went from here all the way to there. Our delta of y would be from 48 to 12, which is 36. And our delta of x would be from 4 to 1, which is 3, and 36 divided by 3 is 12 to 1, which simplifies to our slope of 12. Okay, go ahead and pause the video. Do problem 2. I'll leave problem 1 sitting right there. Do problem 2, and then turn the video back on to check your work. All right, let's see what you did with problem number 2. At 6 a.m., the retention pond had 28 inches of water in it. So let's plot that point. At 6 a.m., there were 28 inches of water. Let me scroll down this a little bit so we can see that the time is the x and the amount of water is the y. So we've got 6 is the time. 28 is the amount of water. The water receded. What does the word receded mean? Think to yourself for a minute. Receded. Well, I think you'll know when we plot this next point. The water receded so that at 10 a.m. there were 16 inches of water. 10 a.m., 16 inches of water. 10 a.m., 16 inches of water. Did you figure out receded means dropped? The water level dropped. What's the slope of that line? Well, there are a couple of ways that we can determine the slope of that line. Let's get your ruler out and let's draw ourselves a line through this. And that's a terrible line. That wasn't me getting my ruler going. All right, now I got my ruler going. So we can go down through this. Take my line all the way down to here. I don't need to put an arrow on this because the water level can't get lower than no inches. Time can't get lower than no time. So I don't need to worry about an arrow at the end of that line. So let me figure out the slope. I'm going to do the same thing. The delta of y changed from 28 to 16. 28 to 16. 28, take away 16, is 12. The delta of x, the change of x. Well, in that same time, x changed from 6 to 10. Now, here's the place you have to be really careful. Before, we were always taking the big number minus the small number, but we have to keep the pairs together. The 6 and the 28 have to stay together. If we go up, I want to point that out again. If we go up to this table where we did all this work, here's the 48 over the 4, 48 over the 4, and the 12 over the 1. Or here's the 36 over the 3, and the 12 over the 1. So when we get down here, we have to decide, okay, we did 28 minus 16, so the x that goes with the 28 has to be right there, minus 10. Now, when you do 6 minus 10, we haven't talked about integers yet. When you do 6 minus 10, you're taking away more than you have. How much more are you taking away? If you do 6 minus 10, ask yourself, how much more did you take away than what you have? Well, 10 is 4 more than 6. So if you think about it, if you break that 10 into a 6 and a 4, and then take your original 6, take 6 away, you're at 0. You're at 0. Now you have to take another 4 away. You're at negative 4. When you do the 12 divided by negative 4, you're going to get negative 3. In this case, the slope equals negative 3. Negative, the way you can tell it's going to be a negative slope if the line goes down from the left. And that means, and it makes sense here, the slope is negative because we were losing water. Just like if this was your money, if this was a graph of how much money you have, that would be pretty negative. That would be a bad thing, a negative thing, to have your money going down. So you have to be careful and remember that anytime the line is going down like this, the slope is negative. And we always have to keep the pairs of numbers together. There is, right there, let me just scroll back on this so we can see it. Right there is the 6 and the 28 inches. And right here is the 10 and the 16 inches. If this is a little bit confusing, don't worry. This is brand new to you, slope, brand new idea. We're going to talk about it over the course of a couple days. Today is not the last day talking about slope, don't worry. Okay, make whatever notes you need to make, and then we're going to flip the page, and we're going to look at a few of the problems on the back. All right, I'm going to flip mine over. Well, I'm going to pause. Actually, I'm going to pause it right there so you can finish your notes. Finish making whatever notes you need to make. I'm going to zoom out a little bit so you get to see more of what we're doing here. There you go. Finish making whatever notes you need to make on those two problems, and then flip the page over and we'll work on the back. Okay, here's a chance to practice a little bit. So if you'll go ahead and start doing problems, and then as soon as you do a problem, I'm gonna go through and talk through all 4 of these. As you do them, you can check out an answer, and if you got it right, go right on to checking out the next answer. If you got it wrong, think about where your mistake was, go back and fix the next one before you look at it. Don't just go through and watch me do problems. So problem number 1, we're finding the slope, hours and wages. You can see they put hours at the bottom, wages. That makes sense. The hours control the wages. So let's go into our table and just quickly label that as X and Y. Here's the X. There's the Y. Our first point is 111. You work 1 hour, you earn $11. Our next point is 222. So 1 hour, $11. 2 hours, $22. 3 hours, $33. And our last point, 4 hours, $44. All right, did that one on that side, but I'm going to shift it over there because it's going to be easier for me to do my stair steps. All right, once you've got those plotted, we are going to draw a line all the way through those points. We'll start at the origin. That makes sense. I did a horrible line there. I got the line tool open and then forgot to grab it. So there's my much better line. And it's going to have an arrow at the end of it because your wages can keep going up for more than 4 hours. And then we're going to find the slope. If we do the change between these two, and notice the change is going to be the same all the way along because we've got this nice line here going through our points. So here our Y changed by 11, from 11 to 22, and our X changed by 1. So the change in Y was 11, and the change in X was 1, or a slope of 11. And what does that stand for? That, in this case, the pay rate is $11 per hour. Make sure that you're doing those. In fact, we should go back. I was not consistent about that. Let's just go back to these two that we did. Our slope of 12 here, what did it show? It showed that there are 12 bottles in each case. Would you go back and write that in so you have it? And then this one, it's really important that we write this one out because with that negative slope right there, we want to be really clear we understand what that means. Since the water was dropping and it went from 6 a.m. to 10 a.m., those are hours, that -3 tells us that the water is dropping at a rate of 3 inches per hour. I didn't write that in earlier, but would you go ahead and write that in if you didn't? Maybe you did. Maybe you were doing it better than I was and you knew to write those things on along. Write them in all along. All right, the water's dropping at a rate of 3 inches per hour. That's what the negative shows you, is that the water is dropping. If it was going up, if this was a rain gauge and you had that same line going up, that would mean the water is falling, like it's raining at a rate of 3 inches per hour. But here the water is dropping, the water is declining. All right, let's go back and I'm going to continue on explaining number 2. And if you haven't done it, please pause the video and do it. Again, don't just watch me do it. So here's my work on number 2. Temperature is my X right there. Number of people on the beach is the Y. When the temperature was 70, there were 24 people. That's going to be right between, almost halfway between 20 and 30. There's my 70. I started to write my Y first by mistake. There's my 70 degrees and 24 people. Then I had a temperature of 78 and there were 40 people. So temperature went up to 78. Some more people showed up at the beach. That makes sense. The weather's getting nice. Then the temperature rose to 86 degrees. And the number of people jumped to 56, just a little more than halfway between 50 and 60. So 86 degrees, 56 people. And finally, when the temps got up there to 94 degrees, there are lots of people at the beach, 72 of them right there, just above 70 on the way between 70 and 80. So 94 degrees, 72 people. Now, this might not be proportional. There's no telling that there were no people when there were no degrees. That'd be like saying, oh, when it was freezing out, there weren't any people. So we're going to connect these dots. We're not really worried about where it touches the y-axis. We do want to continue the graph at least through the edge of the table. And then we want to track what the change looked like. So from this first one right here, our y went from 24 to 40. That's a change of 16. If you do 40 and you take away the 24, 16. So the delta of y was equal to 40, take away 24, 16. That same span, the change in x, the delta of x, the change of x, was 78. That's the one that goes with the 40. So 78 and 40 have to be together, minus 70. That's a change of 8, which simplifies to 2 to 1, or a slope of 2. Now let's see if that slope of 2 is true for the rest of the table. Let's pick another pair that isn't just one apart. Let's go all the way from here to here. So from here to here, the change in y is 72 minus all the way down here to 40. So 72 to 40 is a change of 32. Meanwhile, the change in x, well, we went from 72 to 40, we went from 94 to 78. 94 to 78, which is a change of 16. 78 plus 10 more is 88, plus 6 more is 94, which is also 2 to 1, or 2. So we know that what was happening now is the people on the beach increased at a rate of 2 people for every 1 degree change in temperature. Every time the temperature went up 1 degree, the number of people increased by 2. So the number of people increased, went up, increased by 2 for every 1 degree increase in temperature. Okay, if you got those 2 right, fantastic. Keep watching. If you got those wrong, pause the video, rework the problems, and then turn the video back on and I'll show you the answers to the remaining 2 problems. So here's my work on number 3. I plotted out the points. She swam 50 meters in half a minute. So here are the minutes. You notice they marked at 1, and they skipped 2, skipped to get to 3. So each one of these that's not marked is a half. So a half a minute, 50 meters. 1 full minute, 100. A minute and a half, 150. 2 minutes, 200. I did 2 different slopes. Well, I did the same slope using 2 different sets of points. Here's my first one in orange. So it would be the 150 minus the 50 for the change in y, and the 1.5 minus the 0.5 for the change in x, which would be 100 over 1, or slope of 100. For the second one, I did the green. So the change in y would be 200 minus 150 right here. And the change in x would be 2 minus 1.5, which would be 0.5. And I always want to get back to that unit rate. My slope is always something out of 1. So then I've got 50 times 2. Well, actually here at the bottom, this is how I did it. I did 0.5 times 2 to get to 1. So then I had to do 50 times 2 to get to 100. So whichever one of those you used, here is what your sentence would be. LaTanya swims 100 meters per minute. So write that down and then come back and I will give you my answer to number 4. All right, problem number 4, they actually didn't really complete the instructions here. They said find the slope of the line on the graph showing the cost to download songs, but they don't tell you what it costs to download each song. So if each song, since they put 50 cents here, if each song was supposed to be 50 cents, then your graph would look like this. 3 songs $1.50, 4 songs $2. And your slope, notice that this time, let's get a line through that. Again, starting at the origin, because you don't download any songs, so it wouldn't cost you any money. Downloading would go on. If this was the situation, if each song cost 50 cents to download, notice this time the slope, if we go between these 2 points, here it was 1 song for 50 cents. And here it was 3 songs for $1.50. Notice this time our slope is actually a decimal. The change in y is the 150 minus the 50 cents. And the change in x is the 3 songs that go with the 150 minus the 1 that goes with the 50 cents, we actually end up with 1 over 2, which is a slope of 0.5. So you can have slopes that are less than 1 whole. Later, we'll actually look at slopes that are fractions, slopes that don't have 1 as a denominator at all. All right, so you've got some other problems to work on for homework, and you're going to bring any questions you have in class tomorrow. And I thank you for listening to this lesson on slope.